Hi folks, and welcome to another Python video with me, Richmal Cooper. In this video we'll be looking at the merge sort algorithm and how we could go about solving this problem in Python. This is more of an intermediate level programming task, so if you're a beginner you might want to look at some of my intro to Python videos first. Okay, let's just start off by running this merge sort. Program will generate a list of I think it's 8,000 numbers randomly, and then it will sort them. Okay, and we get an output here uh, that tells us how long it's taken, which is about a quarter of a second. Now, um, well, I could be cheating, so let's just put my print statements back in, and just to speed things up a little tiny bit, let's make that a smaller list. This bit of the program here we'll talk about later. It just creates a random list of 1,000 numbers between 0 and 1,000, and it will print them out. Off it goes. There's all my numbers, and there's the unsorted list there. And there is my sorted list. Okay, and that didn't take very long at all. Obviously, it took a little bit longer than it should have done because it printed out everything, but still quite quick. If you watch the bubble sort video, you'll know that it takes a really long time to sort things using bubble sort, because the longer that you have the list, the longer it takes to sort it, and it's almost if you double the size of the list, you multiply the time it takes to do it by 4. All right, so we probably want to understand a little bit more about how merge sort works. So let's see what's going on. Here's our unsorted array. We start by dividing the array into 2, and we end up with 2 small arrays, A and B, or left and right. We then repeat the process for each of the subarrays. Again, at this stage, we're not sorting at all, we're just splitting the list into elements of eventually 1. And there's our unsorted array divided into individual elements of 1 element each. The next stage is to merge these individual elements. We compare the element on the right to the element on the left, and we sort them, just like we would with a bubble sort. Notice in this particular one, 5 and 8 are already sorted, so we don't need to do anything. 2 and 1 need to be flipped over, 9 and 4 need to be flipped over. Now we're combining the 3, 7 and 5, 8. We compare the leftmost items first. We find that 3 is the lowest. We then compare 7 and 5. We find 5 is the lowest. We then compare 7 and 8. We find 7 is the lowest. And then 8 obviously is the last one. We repeat the same with the right-hand arrays. 1 and 4, 1 being the lowest, 2 being the lowest, and then finally 4 and 9. Now we compare 3 and 1. We find 1 is the lowest. Compare 3 and 2. 2 are the lowest. 3 and 4. 3 is the lowest. 5 and 4. 5 and 9. 7 and 9. 8 and 9. And there's our sorted array. But let's look at how this actually works. So let's just start off with this part of the program here. This is the bit that just creates my blank. It starts off with a blank array and then just populates it with numbers, so I can test my program. And then this little bit of code here, it prints the unsorted array. It will run the merge sort algorithm, which we'll go into shortly. Then prints the sorted array, and it also will calculate how long it took to do it and output that information for us. So I've got the time module. We don't need time module to do merge sort, but we do need it to record how long things take. We don't need the random module for merge sort, but we do need it to generate my list of random things. So that's why that's there. Okay. So we create a function called merge sort, and the input into merge sort is an array. Okay, in this case, it's an array of numbers, but it could be an array of anything. What we now need to do is we need to go through the process of splitting up our list into two. Okay, so we get the midpoint of the array by dividing the length of the array, divide by 2, which gives us the midpoint of array. And what we then do is we continue to do a series of operations as long as the length of the array is greater than 1. So we repeat effectively until the length of the array is 1, and when we get to 1, that's when we stop, because we want individual elements of length 1. And we split that list into two halves, A being the first half and B being the second half. And we're just using a slicing technique there in order to split our list in two, and we're using the variable half, which is the midpoint of our array. What we then do is we recursively split each half of the list. So by calling the function again at this point, essentially what we're doing is we are repeatedly splitting the array into smaller and smaller and smaller and smaller parts until we're left with part 1. Okay, now what I'm going to try and do here is just give us a smaller number of items in our array and just put in a print statement here, so you can kind of see what's happening in the program. All right, so we're looking at A and B as being halves of the list. Okay. So you can actually see the process here. We've originally started off with 100 items, and the 100 items is split into 50, and then it's split into 25, and so on and so on, until we're left with each item in its own individual array. Okay, let's just take those out. Okay, now at this point we define three new variables called arrayPos, apos 0 and bpos, and all of those we set to 0. What we're now going to do is we're now into this bit of the code where we need to start reassembling the individual arrays of length 1 into arrays of larger than 1. So because we've got A, left array, B, right array, and then array sorted array, we need 3 indexes, which we reset to 0. The indexes of both the A and B arrays must be less than the length of the A and B arrays, otherwise we're going to get an index error. For example, we can't look at index 7 of array A if it only contains 5 items. That's why we need to have this condition in the while loop. So as soon as we've compared all of the items in either A or B array, we basically drop out of this particular while loop and into the next part of the program. So let's recap. We've got an A array, a left-hand array, we've got a B array, a right-hand array, and then we've got the sorted array that we're going to append to. So as we looked in the first example, we compare the first element of the A array to the first element of the B array. If the A array item is the lowest item, we append that to the sorted array and increment the position of the A array by 1. However, if this is not true and the B position item is greater than the A position item, then we append the B position item and we increment B position by 1. Once either an A item or a B item is appended to the sorted array, we increment the index of the sorted array by 1. This operation continues until either the A position or the B position is greater than the number of items in the A or B list. So effectively what we're saying is we look at these two arrays here, and we look at we start off by looking at position 0 on, call this one A, and we'll call this one B. That would be index 0 of A, and that would be index 0 of B. And we compare those two, and we say, is this one less than that one? And it isn't. So we append the 3 to this new list, okay? And then we jump to the next item in this array. And now we're going to compare this item and this item. Well, in this case, then we would have to append the 27 because it's less than 43, okay? And now we come back and we look at we're comparing these two items, 38 and 43, and obviously 38 is less than 43, so that one goes there, and then there's only one left, so we put that one there, and so on. So that's effectively what that little bit of code is doing. So let's just try and make sense of this and why we need this code as well. Well, this is fine as long as we've got elements in both arrays. So let's take this one as an example. I'm going to imagine that we're running this little bit of code here, and we will say, okay, so we compare the item 0 of A and item 0 of B, and we say that, well, item 0 of A is less than item 0 of B, so we append that to our array, and then we compare these two items, and then we append that one to our array, and we compare these two items and we append that one to our array, and again we've still got at least one item in both arrays, so onwards we go. 4 and 7 is compared, and 5 and 7 is compared, and 5 goes here. Now we can't continue on in this loop anymore because there are no more items in array A. So all we need to do is append the remaining items from array B, which of course are already sorted, to the sorted array. Obviously, if the situation were reversed and we had array A items remaining, we would just append those to the sorted array. So in this case, we don't need to execute the highlighted code, but we would execute the block of code below because it's array B items, and we just drop those in and complete the merge. This process continues until all the subarrays are merged and we have finally a sorted array. So there you have it, merge sort in Python explained. Hope you enjoyed this video. If you'd like to watch more of my videos, please check out my channel. Thanks for watching.